Okay, let's look at the system of quadrants. Okay, so you see in a graph, where that's the x-axis and this is the y-axis, and put the arrows. Okay, we can define these four spaces, these four regimental spaces divided by the two axes as different quadrants. Okay, so each one is a quadrant, each box is sort of a quadrant. Okay, so just to tell you, x is positive and y is positive here, x is negative and y is positive here, x is negative and y is negative here, x is positive and y is negative here. Okay, so you see in different quadrants x and y are positive and negative, differentially. So when it comes to trigonometric ratios of sine, cosine and tangent, the answers are each positive or negative depending on where the terminal point is. So let's say it's 30 degrees, it's in quadrant 1, and in quadrant 1 this specific trigonometric ratio, one of the sine, cosine or tangent, is positive, and in quadrant 2 something is positive and the rest of it's negative, in quadrant 3 it goes on and on. Okay, so now before I explain why each trigonometric ratio is assigned to one quadrant, let me just give you the general facts. Okay, so all trigonometric ratios are positive in quadrant 1. So this is quadrant 1 and this is quadrant 2. Only sine is positive in quadrant 2, and in quadrant 3 all tangents are positive. Okay, all tangent ratios are positive in quadrant 3, and in quadrant 4 all cosine are positive. Okay, so when we say that sine is positive here, we are saying that cosine and tangent is negative. So if sine is positive, cos and tan are both negative. Okay, cos and tan are both negative. Here sine and cos are both positive, are both negative, and here sine and tan are both negative. So only one trigonometric ratio is positive in each quadrant, with the exception of quadrant 1, where sine, cosine and tangent all have positive answers. Okay, let's give a general explanation as to why that is. Okay, so let's say we have a graph here, and I'm going to draw the 60 degrees triangle. Okay, 60 degrees triangle. So as you can see from this graph, this triangle is in quadrant 1. So do note that all are positive in quadrant 1, since this is in quadrant 1. So I'm recalling the values in the triangle, so that will be 1, square root of 3 and 2. Okay, so now when we calculate the trigonometric ratio of sine, it will obviously be opposite of hypo, which is positive. Okay, sine is positive already. Cos is adjacent over hypo, positive also. Tan is opposite over adjacent, which will be square root of 3. Okay, so sine, cosine and tangent are all positive, but now that is not always the case. Let's say we have that same triangle, the 60 degrees triangle, in quadrant 2. Okay, quadrant 2 over there. Okay, so this will be 1, and because x is negative, see it's on the left side of the x-axis, this will be -1. Y is positive as usual, square root of 3, and hypo is always positive because it's usually a square number, which is 2. Over here it's 2, so hypo is always positive. Okay, so now let's calculate the sine, and since this is 60 degrees, this will become 120 degrees. So the sine of 120 degrees, okay, so 120 degrees is the the terminal angle, and 60 degrees is our reference angle. Okay, sine 120 degrees, which is the same as, okay, we have sine of 120 degrees and 60 degrees the terminal angle. I've already explained in the previous video why that is. Okay, so we have sine of 120 degrees, where 60 degrees is in the second quadrant. So the opposite over the hypotenuse, so square root of 3 over 2. Okay, sine is positive. Cos 120 adjacent of hypotenuse. Adjacent is negative 1 over 2. Cos is negative. Tan of 120 opposite over the adjacent minus square root of 3. So evidently sine is positive and both cosine and tangent are both negative, because in quadrant 2 we can reaffirm the fact that sine is positive, cos and tan are both negative. Let's put that 60 degrees triangle in quadrant 3 this time. Okay, quadrant 3. And this is 60 degrees. So since the reference angle is 60 degrees, for the sake of maintaining that triangle, the original angle will be 180 degrees plus 60 degrees, which is 240 degrees. So the sine of 240 degrees, let me just label 1 square root of 3 and 2. Okay, so here sine x is negative here because it's on the left side of the axis, and square root of 3 is negative because it's on the bottom of the y-axis. It's on the bottom of the y-axis, so this value is negative and this value is also negative. Okay, so the sine of 240 degrees or the sine of 60 degrees in quadrant 3 will be opposite over the hypotenuse, which is the square root of 3 over 2. So sine is negative. Cosine of 240 degrees is adjacent over the hypotenuse minus 1 over 2, which is also sine, cosine is also negative. So the tan of 240 degrees is the opposite over the adjacent minus square root of 3 minus 1 over minus 1. The minus and minus cancel off, leaving us with square root of 3. So the tan is positive. So this reaffirms the fact that tan is positive in quadrant 3 and both sine and cosine are negative in quadrant 3. Now let's put the 60 degrees triangle in quadrant 4. Okay, putting it here in quadrant 4. The angle can either be minus 60 degrees because it's in quadrant 4. It can either be minus 60 degrees or it can be 180 plus 180 plus 120 degrees, which is 300 degrees, or it can also be 300 degrees. Okay, so 300 degrees. So let's 300 degrees, the reference angle is obviously theta is 60 degrees. So the sine of, you can either use minus 60 or 300 degrees because this angle can either be both, it's the same thing. Okay, so if it's 60 degrees, the reference angle is 60 degrees, 1 square root of 3, 2, and since this is at the bottom of the y-axis, this becomes minus, and the sine of 300 degrees opposite of hypotenuse, minus square root of 8, minus square root 3 over 4, minus square root 3 over 2, cos 300 degrees is adjacent over the hypotenuse 1 over 2, and tan 300 degrees is opposite minus square root of 3 over the adjacent minus square root of 3. Okay, so sine is negative, cos is positive, and tan is negative. So this reaffirms the fact that cos is positive, sine, tan are both negative in quadrant 3. Now the exact significance of this, of this will come into play when solving equations. when solving equations, you will understand why this is truly important. When we're trying to find the inverse of sine, cosine, and tangent functions, we will have to apply the rule of quadrants. But for now, you have to understand, you have to memorize the system of quadrants. It is absolutely important that you do. Okay, to memorize, everyone has their own system to memorize the quadrant system to see which ratios are positive or negative in the different quadrants. I'm going to give you my own. Okay, so here we have all is positive here, sine is positive here, tangent is positive here, and cosine is positive in the last quadrant. Okay, so now to memorize this four values, the allocations, I come up with a little mnemonic. You can come up with your own, but see if this helps. So all for the first quadrant, served for sine in quadrant 2, T for tangent, and cups for cosine. So all served T cups, ASTC. So quadrant 1, all are positive. In quadrant 2, sine is positive. In quadrant 3, cosine is positive. In quadrant 4, sorry, all are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. Okay, so see you in the next video. For now, just memorize these four uh, for now, just memorize the quadrant system. I'll explain to you the exact significance of this when we come to solving equations, but this is a very important foundation for what's going to come next. Thank you so much.